Okay, guys, let's have ourselves a prayer. Kind and precious Father, Lord Father, as we're going to begin our lesson, may you guide us, may you help us understand each and everything that you teach us, Lord Father. May you elongate our memories so that we may be able to memorize each and everything and understand it. In thy name I pray.
Amen. Amen. Thank you so much.
Amen.
Okay. Now, I think we are going to agree in order for us to avoid that background noise from people and so on. I'm going to mute everyone. But now, in case there is something you want to tell us, there is something you want to share, then you go on, you raise up your hand, and then you share with us. Because I know there are people who are going to be coming in, and they may have poor backgrounds. Allow me to mute everyone, and then I'll disable. But in case you have, we shall do what we did yesterday, such that we can share together. But the chat is open. We can be able to use the chat to communicate. Very good. So our topic today is trigonometry. This is the topic that we are going to cover. So we know very well today we are looking at pure mathematics. We know very well that at A level, we have two papers. We have the applied mathematics and we have the pure mathematics. So we are looking at one of the basic topics, one of the topics that is applicable to many of the topics that you do at A level. This is the topic you are going to find in mechanics, is the topic you are going to use in applied and many of the topics. So it's the foundation for many of the topics that we do at HSC. So when we are looking at this topic, I want to ask you that to pay attention. Any step that you have not understood, please ask, and then we shall be communicating such that you can be able to understand every part we are going to look at. So I expect you now to write your heading, trigonometry. Okay, now I'm going to first take you back a bit of history. How did this trigonometry come into play, or what is trigonometry? So trigonometry means a free angle measurement. So what happened some years back when one of the gentlemen, Harris, visited Cairo, he noticed that they had very many pyramids, and he asked himself, but what is the height of that pyramid? And when he asked all the villagers around, no one could tell the height of that pyramid you are seeing. And then he kept wondering, why are people not able to tell me the height of this pyramid? So this gentleman went on and discovered and said, what can I do in order for me to find the height of that pyramid? So this gentleman went on and developed what you call right-angled triangles. So this gentleman went on, the one called Forrest, went on and looked at the right-angled triangles. And it is from that idea where he got that question that puzzled him, what is the height, that he came up and he noticed the relationship that is existing between the different sides of the triangle. So when you look at the pictures, these are the pictures he was able to come up with that gave him the idea of coming up with this topic of trigonometry. So when we are talking about trigonometry, we are mainly looking at the relationship between the sides of the triangle. When you look at that triangle, what kind of relationship is existing? So this is where this subject is originating from. And where do we apply? So he came up and he did a lot of calculations. And then he was able to find out the height of that pyramid. Where do we apply trigonometry? When those people are going to be going into land surveying, navigation, physics, and engineering, all these areas will involve in the use of the ideas of trigonometry. And currently, it is mainly being used in, it is used in astronomy. People are going to be studying things like stars, things in space. People are going to, who want to predict the when will it rain, who, in which year shall we experience earthquakes and so on. Then you need this idea of trigonometry. When they are constructing things like bridges, those who have been to Ginger, here they use the knowledge of trigonometry. So those are some of the applications. And what is our course outline? What are we going to look at? Now, in this topic, we have to, this is the first, let me call it the first subtopic we are going to look at. And it's going to be mainly concerned with what we call trigonometric ratios. So under trigonometric ratios, we are going to first look at right angled trigonometry. We shall look at ratios for special angles. We shall look at the quadrants. We shall look at the graphs, identities, equations, and then lastly, parametric equations. So this is what we call trigonometry 1. Then after understanding the foundation, the background, then we shall go on and look at trigonometry 2, which will involve a lot of double angles, a lot of different identities. But this is what we are going to first look at today. So I want you to ask you to first summarize these different things we are going to look at today. So summarize and then we'll continue. When you finish, you just type in the chat that we have finished and then we'll continue. Okay, people are saying they have finished. Very good. Now, why am I giving you this outline? This outline is to help you to read, to know which areas should I know in this part of trigonometry. So that is why I gave you those parts. Okay, I think we can continue. Those who have not be able to take a screenshot. So we are going to look at a brief introduction. Now, when they talk about the word trigon, it means a triangle, and metria means a measurement. So when we talk about trigonometry, is a branch of mathematics. At times we can call it even like a discipline of mathematics in which we study relationships that are existing between the sides and the angles of triangle and their measurements. That is very important. So I want you to just summarize, make a simple summary of what is trigon, because even I want you to be in a position to explain when someone asks you, what do you understand by trigonometry? Then you tell this person that I'm looking at the measurements and I'm looking at the triangles and how the sides are being related. Now at O level, we look at the three ratios, which is sine, cosine, and tangent. And these are what we call the principles. These are what we call the mothers from which everyone is going, from which we are going to get other ratios that do exist. There are other ratios that we have not yet looked at, but it is from these three where others come from. So the moment you understand these three, it is an implication that the rest are going to be very Okay. Okay. So first summarize. When you finish, you let me know that I have finished the summary. Yes. It is always very good to have a bit of introduction such that in future you can be able to explain. So summarize. When you are done, you just say, I have finished. Okay, so if I'm seeing 5 people are confirming that they have finished, the rest, are we progressing well? Please let me know whether you have finished. Okay, those who have not finished, please let's learn how to take a screenshot. You take a simple screenshot that will help you to, okay, very good, perfect. Okay, we can continue. Now, we are going also to remind ourselves, when we are dealing with trigonometry, it is always important for you to know the angles we are dealing with. I understand we know angles. So the first angle we need to know, because here they may use words, that the angle is acute angle. What do we mean by an acute angle? So when we talk about an acute angle, is that angle that is between 0 and 90 degrees. Who can give us, can someone in the chat type any angle you know that is between 0 and 90? Any angle you think is an acute angle in the chat there. Very good, Emma. Very perfect. Good, good, good. Yes, all those angles, please put them here. Put them here. At 30, I've seen 89 degrees. Put them there. Very good. Can we give, okay, when the second one is the right angle, and that one, everyone knows that right angle is 90 degrees. Then we have another type we call obtuse angles. Please, in the chat, can we put some obtuse angles? Hey, put some. Say this is an obtuse angle. Very good. Perfect, perfect, perfect. Yes, yes, this is very good. Interesting. I don't know why K likes 179, but that is very correct. Please put some angles, 179, put 135, and so on. Those are what we call the obtuse angles. Then the last angle, we have what we call a straight angle. A straight angle is one that is equal to 180 degrees. Then the last angle, I think I have not mentioned. Let me see whether people know it. Type in the chat. The E, part E, there is another angle I have not included here, but I want to find out whether people know about that angle. Type in the chat. Which type of angle? Very good, Timothy. Very good. Yes. The last one is what we call a reflex angle. Yes, we call it a reflex angle. So when we have an angle is a reflex angle, an angle is a reflex angle if it is between, who can tell us in the chat again? An angle is called a reflex when it is between, I'm waiting in the chat. An angle is called a reflex when it is between, very good, very good. Yes, Rosemary. I'm saying now very things. Okay, some are saying 180 to 360, others are saying 270 to 360. Yes, but I'm saying the majority are saying 180 to 360. Very good. So that is it. So it is between 180 degrees and 360 degrees. Those are what you call the reflex angles. Now, these words must be familiar to you, such that when they use it in a question, you can easily tell. Because here at A level, we specify, we say we want an obtuse angle. That means that you need to, your answer must be an obtuse angle. When we say we want an acute angle, you need to know that an acute angle, the answer I get, I must write it as an acute angle. Therefore, in summary, when I draw my circle like this, what we have noticed that here we have 0 degrees, we have 90 degrees, we have 180 degrees, we have 270 degrees, and lastly, I have 360 degrees. So all angles, the first one is what we call the acute angle. Then I have what we call the obtuse angle. Then down here is where we have what we call the reflex angle. So please summarize it like that, such that you know I have acute, obtuse, and reflex, such that you have them mastered in your head. Some people even at times they can put a small thing to remember them, that always I use OR. Some people, you can summarize them and say, my angles, I remember them using AOR, acute, obtuse, and reflex angles. Please let me know whether we're on the same page and we continue. Are we on the same page? Just say yes and we continue in the chat. Very good. Perfect. Perfect. Yes. So any angle between 180 to 360. Let me hope people will have put some example. Put some example of any angle. Yes. Then this angle 360, we call it the follow angle. So as a mathematician, at times when you are speaking in mathematics, you need to use some of these these words, that it is a full angle. Okay. Very good. Perfect. Yes, people have finished. We can continue. Okay. Now, the first things we are doing, we are looking at, I'm just taking you back to O level such that we can be on the same page. Now, when we talk about trigonometric ratios, like we have said, we are going to look at sine, cosine, and then the tangent. However, you had a background in O level about these things, but now I want to just remind you what we looked at. One thing we looked at is what we called the hypotenuse. Now, I want you to please note that any side on your triangle, the longest side is always what you call the hypotenuse. No matter how your triangle is looking like, for you just identify what is the longest side on that triangle of mine. Even if your triangle is facing like this, for you identify which side is the longest is what we call the hypotenuse. Number two, what we call the adjacent. When we are talking about an adjacent is the base where you start measuring your angle from. When we are measuring angles in trigonometry, we always have a base. It's like when you're constructing a building, you always have the base you start from. So when I'm measuring this angle, where I start measuring from is what you call the base. And this base is what forms what you call our adjacent. Then, when you look yourself into the mirror, what you see is what you call the opposite. So our angle here, theta, where it is facing is what you call the opposite. When you look yourself into the mirror, where you see, at times even you can say, where your angle is where you're placing your eye. This is like where your eye is. So what you see in the mirror is always your opposite. So when you are labeling your triangle, the first side that you can first label is what is your opposite. This opposite will help you to know now where am I going to place my adjacent and where am I going to place my hypotenuse. And I've told that when we are measuring, the base is adjacent, hypotenuse is the long side. And how do we abbreviate them? When you find HYP, it stands for hypotenuse. OPP, opposite, and ADJ, we can abbreviate it for adjacent. In case you have any question, feel free to raise up your hand, because now this is the key thing that everyone, this is where the spice, this is where now we are going to start putting in the different spices in our meal. And once we leave you from this point, things might be very hard. So in case you have any question, feel free to ask. But in case you have understood, just say in the chat, we continue. So I'm waiting to see some message in the chat to permit me to continue. Okay. Okay, very good. Perfect. People are saying we continue. Good. Yes, now we are going to derive what we call the trigonometric ratios. And the first trigonometric ratio we are going to look at is, I'm going to first teach you how we write the sides when it comes to a triangle. Now, when I have any triangle, let me say this is my triangle. How I label my sides matters a lot. When I put here A, it means that the angle I have here is A. Now, this side where my angle is going to face, I will call it small a. In case I put here B, that means that this angle here is the angle B. So where it looks down is what I will call B. Then I can put my C here. In case this is my C, where it faces is what I call my side C. So when I use capital letter will mean an angle. When I use a small letter A, this one means the length of the side. This is the length of the side. Now, what is the first trigonometric ratio we are going to look at? We are going to look at the first one we call sine of A. When I have sine of A, let me check whether people remember. Let me check. Can you type, how do we get sine A? Oh, someone, Letitia, are you able to hear? Yes, I want to find out, how do we get sine A? I want you to tell me that when I'm getting sine A, I use this and this. Very good, very good. Perfect, perfect. People are remembering the acronym, what we called. So I write it for me like this. So Toa. Very good. Now we know that sine A is the first one, which is opposite over hypotenuse. Now, when you look at our triangle here, we have already labeled our opposite is this side here, which is A. So meaning I'll have A out of hypotenuse, which is C. So meaning that my sine of A is the same as A out of C. Please, why don't you find what is cos A? And also you find what is tan A. Find those ones. Feel free to type in the chat and we see who needs some help on those ones. I don't know. Okay. People really look very confident that they know these things. Very good. Yes, this is perfect. Perfect. Okay. Yes. So some people have told us that cos of A is B out of C and tan of A is A out of B. So please, those who are finding it a bit hard, you look here. Where you have adjacent out of hypotenuse. Opposite over, before you just do like this. You know, opposite hypotenuse. Adjacent hypotenuse. Opposite are adjacent. Hope that one is very okay. Now, at A level, allow me now to introduce for you a new one you have not heard about. But I know some of you would read your head. You might have heard about it. I'm going to introduce another one. And this other one I'm going to introduce is what we call the cosecant. But before we continue, let me first show you one relationship that we need to know. When you look at tan A is given by A out of B. However, from tan A, I'm going to reduce some relationship. When I have A out of B, let me first ask, when I have 2 out of 3 and I multiply here by 2, okay, let me say by 5, and I multiply by 5, have I changed anything on this number? Initially, I had 2 out of 3, and now I'm multiplying up by 5, down by 5. Have I changed anything? Is that number the same or things have changed? I want to first know what you think. No, very good. We have not changed anything. Now, allow me to introduce something here. When I multiply here by C, and then I divide by C, I want you people to look at it very well. You are not seeing this C can easily cancel, and I remain with the same thing. I remain with the same thing. What am I going to have? I'm going to look at the relationship. Allow me now to write it in another way as A out of C times C out of the B. And what am I driving at? You are not seeing A out of C is the same as sine of A. What about C out of B? I'm going to come here and I show you something. When I have cos of A is equal to B out of C. When I write 1 out of cos of A, it means that my answer is going to change and I have C out of B. Please let me know whether you have understood this part here, where I'm saying 1 out of cos A is the same as C out of B. In case you have understood, just write in the chat here. Okay. In case I want people who have understood, yeah, people have, okay, good. Understood. Okay, let me repeat once. We know very well that cos of A is equal to B out of C. However, when I have, let me say I have 1 here, because I know there is a 1 here, and I cross multiply like this, I cross multiply. It means I have C cos of A is equal to B. So when I divide by cos of A, it means I'll have C is equal to B out of cos of A. So in case I want to remove this B, I'm going to divide by B, I divide by B. So this B and this one will change. So I remain with C out of B is equal to 1 out of cos of A. In simple terms, when I have 2, I can write it 2. When I have a number, we are getting, maybe I say 2 is equal to X. When I get a reciprocal, I can say 1 out of 2 is equal to 1 out of X. These are the same things. So in other words, when we are getting the reciprocal for our cos, so you can interchange, this is the mathematics behind, that C out of B is the same as 1 out of cos of A. Now, when I come back here, where I have my C out of B, I'm going to replace with 1 out of cos of A. Where I have A out of C, I'm going to replace with sine of A. So I'll have sine of A times 1 out of cos of A, which is going to give me sine of A out of cos of A. Please, if you have understood that part, just say yes. Yes. In case you have any question, please ask. Oh, okay. Have people understood? Very good. Perfect. Yes. In case you have a question, please feel free to ask. At least that is so promising that people are understanding. Now, I want you to take it from today onwards that whenever you have tan of A is the same as sine A out of cos of A. We have started looking at now new relationships. Tan of A is the same as sine A out of cos of A. Even if, yes, first write that. Yes, let's write and then you let me know whether you have finished. When you finish writing, you say finished. Yes. write that. So whenever you meet tan of A, you say it's the same as sine out of cos. Okay, people have finished. Very good. Okay, perfect. We continue. Okay. Now I'm going to show you another relationship. These ones now. The first one we have said, who can tell us when I have tan of theta, okay, let me use the letter that is easy to write. Tan of B, what is this one equal to? Write in the chat. Tan of B, what is it equal to? Tan of B, what is it equal to? I want you to express it for me in terms of sine and cos. When you have tan of B, what is it equivalent to? Very good. It is the same as sine of B out of cos of B. Very good. So even if you have tan of 60, still you say it's the same as sine of 60 out of cos of 60. Another term we are going to look at, another relation, is what you call a cosecant. When we talk about cosecant, please, these are good vocabularies that we are going to learn. However, cosecant, like we have, like when you look at cos, we call it cosine. Now, a cosecant also comes from cosine. So we abbreviate it as cos. Now, when I'm talking about cosecant, I represent it with cosec. Now, when they talk about cosec, take an example what we have been looking at. Cosec of A is the same as 1 out of sine of A. Please take note. When I have another one, this is cosecant. We have what we call a secant. A secant means we abbreviate it as sec. So sec of an angle, say A, is the same as 1 out of, let me see, people guess, what is sec equal to? In the chat. Very good. Sec is the same as 1 out of cos of A. Very good. You people are going to enjoy trigonometry. Then the last one, we call it the cotangent. Cotangent. And cotangent, we abbreviate it with cot. Let me see people guess here. I want to see when I have cot of A, what is it equivalent? People have already taught. Perfect. Yes, that is very good. So cot A is the same as 1 out of tan of A. Beautiful. Beautiful. Yes, yes. Thank you, everyone. Let's write them down. Yes, even which you can abbreviate it as cos out of sine. In simple terms, cot, we have said, is the same as 1 out of tan of A, but we know that tan A is the same as sine A out of cos of A. So in simple mathematics, you can write it as 1 divided by sine A out of cos of A, which you can write as 1 times, you take the reciprocal, cos A out of sine of A. So this one will give you cos A out of sine of A. So cot is the same as also, is the same as cos out of sine of A. Perfect. Has everyone finished? Just say yes in the chat. In case you have finished, say yes, and then we continue. I've seen 2 people saying they have finished. Okay. Okay. Okay, very good. Please, in case we are leaving you behind, please tell us such that we go on the same page. I have a number. So we are going to look at angles between 0 and 90, what we call the acute angles. Now I'm going to do only one, then the rest you do. Now, when I look at cos theta is equal to root 5 out of 3, what am I going to know? When you look at part 1, we know very well that cos squared theta means cos of theta times cos of theta. Please take note of that. When you see cos squared, in other words, cos theta squared means cos theta multiplied 2 times, which is the same as cos theta times cos theta. In case here there is 3, it means you multiply it 3 times. In case there are 4, it means you multiply it 4 times. Now, this means that our cos theta, they have told us, is root 5 out of 3. So I'll come here and I write root 5 out of 3 times root of 5 out of 3. So we looked at surds. So root 5 times root 5 in surds, we know that that is the same as 25. Remember, in surds we say root of A times root of B is the same as root of A times B, which is the same as root of AB out of 3 times 3, which is 9. But root of 25 is 5 out of 9. So this is our equivalent of cos squared theta. Please let me know whether that step is very okay for everyone. Is the step fine? Any questions? Please feel free to ask. Okay, people are saying the thing is okay. Very good. Now we are going to look at part 2. Now to do part 2, they want us to find sine theta. But like we have said that our angles is between 0 and 90. And that means that our angle is an acute angle. So in any quadrant, when I draw like this, it means that that angle is in this first quadrant because this is where we have the acute angles. So that means that I have my angle here, theta. But like we have said, you need to know what is cos theta equivalent to. That cos theta is given by adjacent out of hypotenuse. So you compare that I have root of 5 and I have 3. So when I draw my triangle like this, you need to know where are you going to place them. That this is theta. Where is my adjacent? It is down here. Where is my hypotenuse? That it is here. So what is my task? My task is to find out what is the opposite. Let me put our opposite to be x. Can everyone first find out what is x? Using the method of Pythagoras theorem. Find x and you tell us in the chat what you are coming up with. Find x and you share with us what are you coming up with. Oh, Ashraf, I've not gotten you what you were trying to say. Okay, Alvin is getting 2. The rest, let's use Pythagoras theorem. Okay, we need 2, Mildred 2. Ernest 2, Mulindwa 2, Richard 2. 2, 2, 2. Very good, very good. Anyone who is not getting 2, such that we can help. 2, 2, 2. Very good. Everyone is getting 2. Yes, like we know very well that the Pythagoras theorem, it means a squared plus b squared is equal to c squared. And you know that c is your longest side. So that means I can say root of 5 squared plus b squared is equal to c squared, which is 3 squared. Root of 5 squared is 5 plus b squared is equal to 9. B squared is equal to 9 minus 5. B squared is equal to 4. And when you get a root, you get your b as 2. So people are very correct. So So our x this side is 2. So can we go on and now find out what is our sine theta? What is the ratio of sine theta? And also find what is the ratio of tan theta. Type your beautiful answers in the chat as well. What you are getting for sine theta and what you are getting for cos. Okay, Derek is getting 2/3. Alvin is getting 2/3. Mildred is getting 2/3. Engineer Twin 2/3. Isla 2/3. Carol Karen. That is very good. 2/3. So I'm waiting now. Let's also get for tan. What are you getting for tan? 2/3 bias, Richard, that is very good. Steve, Skeva, Timo. Derek, now we are on tan, very good. Derek is getting 2 out of root of 5. Yes, 2 root of 5. This is very nice. Okay, Tekino is still on part A. Okay, beautiful. Moncasta, Jane, Ashraf. Wow. Good. The answers are really very beautiful. In case you have any questions, feel free to ask. Otherwise, now we can continue. I assume everyone has understood. Now, we are going to the part of show. Now, please take note. When they tell you show in mathematics, it means that you are moving from the left-hand side, going to the right-hand side. That is what we call show. That is what we call show. That is what we call a show. That means you are going to move from your left-hand side and then you go to the right-hand side. That means that when you are proving, you start from the left, you go to the right. Then when they say prove, when they tell you prove means feel free to move from any side of your choice. So you can move from one side, you go to the other, one side. It depends on how the number is. There are numbers that may be easy to move from left to right. There are numbers that may be easy to move from right to left. So always check out the question and then find out. Now, the first thing I'm going to ask everyone to do is to first find out. We are moving from the left this side and we are coming to the right. So I want everyone to first find for us what is the equivalent of tan squared. Find for me that and put it in the chat. What is tan squared? So we are complacent. Another one, first find that and you tell me what you have. Find that and then you tell me what you have. Okay, I'm looking in the chat to check out what do people have for tan squared theta. Only. Very good. That is perfect. 4 out of 5. Very good. Now I'm going to leave you to do it. 4 out of 5. Now I want you to substitute. We are breaking the question. Now the next thing we are finding is what is cos theta plus sine theta? We have our answer for cos theta. We have our answer for sine theta. Let's get it. The next thing I want you to get from me is what is cos theta plus sine theta in a simplified form. First get it. Get it? Calculate what is cos theta. I'm waiting in the chat. Some are saying, okay, good enough for tan squared. Everyone got 4 out of 5. Okay, I'm waiting. The rest are still trying out. We need more 10 people. Let me first even mute a bit. Okay. Thank you, people. These answers are very okay. The answers are very beautiful. So we are going to prove. So whenever it comes to proof, handle it in steps. That's when you are going to enjoy it. So I'm just putting it here aside. We had our sine theta. Sine theta was 2 out of 3. Tan squared theta was 4 out of 5. Cos theta was root of 5 out of 3. So allow me to do cos theta plus sine theta. I know it is 2 out of 3 plus root of 5 out of 3. And we know very well that these numbers have the same LCM. I can just add. So it is same as 2 plus root of 5 out of 3. Now, what do I don't want you to write? One thing, please, whenever you have a sad in your answer, never write it like this, that root of 5 plus 3. This one, if at all you are not careful, you may end up adding 5 plus 3. So that is better. Always start with a number, but the moment you mess up, you may end up adding them. So now we are going to go back. Our original thing was 1 minus tan squared theta. So I want you, please, also simplify. What is 1 minus tan squared theta? 1 minus tan squared theta. Simplify and tell me what you get. Quickly. What do you have? 1 minus tan squared theta. Okay. Sharon is saying 1 out of 5. Karen is saying 1 out of 5. Angela, 1 out of 5. Esla, 1 out of 5. Very good. So I have this as 1 out of 5. So I go back. I say my original thing was 1 minus tan squared theta out of cos theta plus sine theta. So this one is going to be 1 out of 5 divided by 2 plus root of 5 out of 3. Now, what are we going to do? We are going to say this is 1 out of 5 divided by 2 plus root of 5 out of 3. Now, we shall continue and say that this is the same as 1 out of 5 times. Now, we get the reciprocal. This one comes up, this one comes down. So we shall have 3 out of 2 plus root of 5. So this will be 1 times 3. I multiply these ones. I'll end up with 3 out of 5 into 2 plus root of 5. But what are you not seeing? Our equation or our proof they wanted us to get. They told us it must be equal, or we must obtain 3 root of 5 minus 6 out of 5. That's what they told us. Now, here we learned surds. I remember you learned surds in I think first term. We did some surds in our schools. So that is what we are going to do. We are going to rationalize. So we know very well that when you are rationalizing a surd, allow me to write it somewhere here. Okay, let me write here. It means I'm going to have 3 out of 5. Allow me to put a bracket here. I'll have 1 out of 2 plus root of 5. So I rationalize this. So when I'm rationalizing, I look at the sign between the two numbers, and I know very well the sign will have to change, what we call the conjugate. So I'll have 2 minus root of 5 out of 2 minus root of 5. So this will equal to 3 out of 5 into 2 minus root of 5 out of, can I just put it in a difference of 2 squares, that this is 2 squared minus root of 5 squared. So I'll end up with 3 out of 5 into 2 minus root of 5 out of 2 squared is 4 minus 5. Let's hope we are on the same page. So I'll have 3 out of 5 into 2 minus root of 5 out of negative 1. So this one is going to give us, I can multiply it by negative 1 up and down. So that means I can have, when I multiply by negative 1 up and down, I'll have negative 3 out of 2 minus root of 5, and down I'll have to remain with only 5. Like I'm multiplying a negative up, I'm multiplying a negative down. So negative times the negative, you get a positive. This negative 1 will multiply the 3. So this will yield negative 3 times 2, which is negative 6, negative 3 times negative root of 5, which is plus 3 root of 5 out of 5, which now I can arrange and write it as 3 root of 5 minus 6 out of 5, like what the question wants. In case of any questions, please feel free to ask. Raise up your hand and you let me know where you're lost from. In case you are lost, kindly raise up your hand and then I make some emphasis. Yes, Tekino.
So I was requesting you to pardon from the rationalizing part.
From the rationalizing part, okay. Sheila, Rahman.
So I'm not from where I'm multiplying by negative 1 on both areas.
Okay.
Like the other side.
Oh, okay. Now I'm going to use this space for rationalizing. Now, let me start with the first one, taken. Now, when I have a number 1 out of 2 plus root of 5, when we are rationalizing, we look at the denominator. The sign between them is changed, what we call the conjugate. In case you had 2 plus root of 5, then this one becomes 2 minus root of 5. In case it was a minus, it becomes a positive. So you multiply that conjugate up and down. So here you have not changed anything. So when it comes to 2 plus root of 5 down and 2 minus root of 5, feel free to multiply, like how we open brackets. I will say 2 multiplies everything this side. So I say 2 into 2 minus root of 5. You open your brackets. Plus this root of 5 multiplies here. So I'll have root of 5 into 2 minus root of 5. Now I open. I set 2 times 2. That 2 multiplies the 2 minus 2 root of 5 plus 2 root of 5 minus root of 25. So I'll have 4 Negative 2 root 5 plus 2 root 5 is 0. So I'll have 4 minus root of 25, which is 5. So I end up with negative 1. That means that down, I'm remaining with negative 1. When I come up, I have 1 times 2 minus root of 5. Divide by now negative 1. So 1 times anything, it is the same as that thing. So I have 2 minus root of 5 out of negative 1. But when I have this negative 1 divides the 2 and divides the root of 5. So that means I can write it as 2 out of negative 1 minus root of 5 out of negative 1. So this negative and this one cancels. So 2 divided by negative 1 is negative 2. So you end up getting negative 2 plus root of 5. So this is what now is going to remain. In case this one is confusing you how to multiply negative up and down, then you do it from here. That this 2 minus root 5 out of negative 1. Here, this step here, you divide each individual term by that negative 1. Now you know whether now we are together. Tekino, are we together? Yes, Rosemary.
Yes. Excuse me, teacher, I have a question.
Yes.
On this step for 3 out of 5 in brackets 2 plus root 5, what if we multiply by 5, like so that we can stop having those big brackets?
Oh, it is very okay. Very okay, Rosemary. You can say 3 out of 10 plus 5 root of 5. That one is very okay. It is very, very okay. Okay. Okay, I think now people are on the same page, unless someone has a question. I think we can continue. Can we continue? Can we continue? Just let me know in the chat. Yeah, but I saw a hand up. Yes, Rahman.
So now, so can you help me and you go through that thing of 3 out of 10 plus 5 root 5?
Oh, okay. Let me see whether I can. Let me do something. Okay. Sorry. Okay, sorry, let me. So someone wanted us to go through. Let me just look at it briefly. So now that one, I think was it? I think it was 3 out of 10 plus 5 root of 5. Please help me to confirm whether that was like that. Was it like that? Let me hope so. Okay. Someone. Yes, okay. People are saying it was like that. Yes, now this one, when we are rationalizing, I will say 3 out of 10 plus 5 root of 5 times 10 minus 5 root of 5 out of 10 minus 5 root of 5. However, here you're going to allow me to use the simplest part. We know very well that when I have a squared minus b squared, this is the same as a plus b, a minus b. When you look at our two denominators, you have 10 plus 5 root of 5 into 10 minus 5 root of 5, meaning that our a is equivalent to 10, so this is our a, minus b, which is the whole of this, so which is the same as 5 root of 5 squared. So this is the same as 100 minus. Now, when I have 5 root of 5 squared, it means it is 5 root of 5 times 5 root of 5, which will give me 25 root of 25. So this one gives us 25 times root of 25, which is 5. So when I have 25 times 5, I'll end up with 125. So here I'll have 125, and 100 minus 125, I end up with negative 25. So I will come back here. That means that down, I'll have negative 25. So I will come and say 3 into 10 minus 5 root of 5 out of negative 25. So which I can continue and write as I enter the 30, I'll have 30 minus 3 times 5, which is 15, root of 5 divided by negative 25. So this is the same as 30 out of negative 25 minus 15 root of 5 out of negative 25. So now you can reduce and say 30 goes in 25 how many times? And then you say by this is 6 and this is 5. So that means you have negative 6 out of 5. Then this negative and this one cancels. 15 goes how many? It will be 3 out of 5 root of 5. So this one will yield, since the LCM is the same, it means it's the same as 5, negative 6 plus 3 root of 5. And I think the question wanted us to write it like this. So that's how you do it. Whatever means you use, you can do it. Okay, yes, Sheila?
So now I think this is the best method we can use.
Okay, it is okay, Sheila. Okay, thank you. Okay, I think now we'll continue. Okay, now these numbers are for you to try out. This is your activity to try out. So take a screenshot. Take your simple screenshot. And when you finish, you let me know. Has everyone taken a screenshot? Oh, finished. Yes. Okay, perfect. So these are the numbers you're going to try out following what we have been looking at. Good. Now we go to the next part, what you call trigonometric ratios of special angles. But in the chat, let me see whether people know what we call special angles. Type in all the special angles you know in the chat. Type in the chat, what are special angles? Which angles do you know that are special? Good, 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 good. Very good. Yes. Now, the first one we are going to start with is what you call a right-angled isosceles triangle whose two equal sides are of length 1 unit. So I'm going to draw my right-angled triangle. Draw a better one. Draw a better one. This is 90. This side is 1. This side is also 1. And I'm going to place my angle here as maybe theta. Now, here when it comes to trigonometry, you are going to hear a lot of theta, beta. Yes, we mainly use the Greek alphabet. So now, my task, in case, let me call this one to be, this side is C. Can people type in the chat, what is their side C? What is the length of side C? Type in the chat, what are you getting for your length of side C? I want to see what people are getting. Very good, very good. Everyone is coming up with the root of 2. Very good. So this side is going to be root of 2. Even if now I remove this. Very good. Thank you, people. That is beautiful. So that side is root of 2 because we have said a squared plus b squared is equal to c squared. So this is 1 squared plus 1 squared, which is c squared, which is 1 plus 1 is equal to c squared, 2 is equal to c squared, and you get the root of 2 is equal to c. Now, when it comes to an isosceles right-angled triangle, this is the special triangle that we use to calculate special angles. Let me see whether people know which angle we're going to put inside there for that special triangle, right-angled triangle. Which angle? Very good, very good. 45. So the angle we have here is going to be 45. So it is that one that deals with 45. Now, let everyone find for me, what is sine of 45 equaling to? What is cos of 45 equaling to? What is tan of 45 equaling to? But we have also learned about cot. Let me test you. What about cot 45? So give your answer of all those ones, what you have. Sine 45, cot 45, and yes. Yes, I'm seeing beautiful answers in the chat. The rest, are we getting the answer? The rest, are we getting the answers? Okay, beautiful. I should have checked out your 2. So sine 45. Can someone raise up the hand and you tell us what you have? Sine 45. Who wants to tell us what you have? Raise up your hand. Okay, Adams.
Sine 45 is 1 over root 2.
1 out of root of 2. Very good. Thank you. I have Derek. Okay, Derek.
It's the same thing.
The same thing. Okay. Same thing. Okay, good. Ezra, tell us for tan. Ezra, tan.
145 equals 1.
1. Very good. Then lastly, Karen, tell us for cot. Karen.
Cot 45 is 1.
It is 1. Okay. 1, 1. Kathy is saying, I'm lost. How did you get cot 45? Kathy, we know very well that cot 45 is the same as cos 45 out of sine 45. Or cot 45 is the same as reciprocal of 1 out of tan 45. But we know tan of 45 is 1, so you get 1 out of 1, which is 1. Alternatively, use this approach. Okay, someone is asked, yes, Alvin, that one is also okay. Yes, Alvin, that is okay when you rationalize. Okay, that is okay. Then we go to the next one. We call an equilateral triangle. Now, an equilateral triangle, it is a triangle of this nature. However, we have said we are going to use length of 2 units. So this is going to be 2, 2, 2. However, when I draw perpendicular from up here, it will divide my triangle into 2. So this one is going to be 1, and this is going to be 1. So when I try to cut out something, I'll have something like this. I have 1, I have 2 here. Can people find out what is our x here? What is the length of x? Find what are you getting for your x? Root of 3. Very good. So x is equivalent to root of 3. X is equivalent to root of 3. So this is root of 3. However, for an equilateral triangle, all angles are equal. So this is 60, this is 60, and up here we have 60. However, when we cut, we shall remain with 30 here. So that will be 30, 60, and then 90. So people, can you find out what is sine 60? What is sine 30? What is tan 30? What is cos 30? What is the cos 60? Find all those ones. Find all those ones. And I'm going to request one person who can sing a hand up. Who's that one? Oh, this is Derek. Let me, I think Derek forgot to mute. I want to ask someone to raise up your hand and you tell us what you are getting. Raise up your hand. Atwine. Oh. Adams?
Sine 60 is root 3 over 2.
Sine 60 is root 3 out of 2. Good. I've seen a team Mercy. I saw a team Mercy. Or Mercy's Carol.
Sine 60 is, sorry, sine, which one, teacher?
Sine 30.
Sine 30, I have a half.
Half, good. Another, Karen Barasa.
Yes.
Tan 30. What do you have, Baraka? I saw your hand up.
So I wanted to answer sine 30. It's okay.
Okay, tell us tan. Tell us tan.
Okay.
What is tan?
One out of sir.
1 out of?
Radical 3.
Yes?
1 out of radical 3.
Okay. Thank you. Then I'm seeing Mile. Mile, unmute. Mile?
Cos 30.
What is cos 30?
Root 3 over 2.
Root 3 out of 2. Then Collins, what is cos 60? As if I saw Collins talk.
Cos 60.
Yes.
1 over 2.
1 out of 2. Okay.
Yes.
Very good. Thank you. Then who has not given anything? Okay. Derek, unmute Derek. Derek?
Tan 60, root 3.
Okay, tan
60 is root 3.
Okay.
Tan 60 is root 3.
Okay, thank you, Derek. Okay, let me hope that part is okay for everyone. Okay, thank you, people. Can we continue now? Just say yes in the chat and we go on. In case you think we can continue, say yes, and then we continue. Okay, good. Try for me that number. We are trying that number now, everyone. When you get your answer, post it in the chat. Okay, Ashraf has a question. Ashraf, raise up your hand such that I can get you. Ashraf, ask. Unmute.
I have a question.
Yes.
But is it fine to get the third from the denominator and make it a numerator? I put
Yes.
it up like we had 1 over root of 3. And instead we get root 3 over 3.
Perfect. It's very fine.
Okay, sir.
Very okay. Like for this number, I want you to give me the exact value. So I'll expect people to rationalize after.
Okay.
Okay. I'm waiting for the answer. People are getting root 2 out of 4. Okay.
Yeah.
Yeah. Are people getting root 2 out of 4? Yeah. If at all that is what we are getting, you people, you are very, very, very bright. That is very true. Sine 30 is a half times cos of 45.
Radical 2 out of 2.
Which is?
Radical 2 out of 2.
Radical 2 out of
2. Yeah.
Okay, first give it to us before you reach radical 2. Cos 45 is equivalent to? Okay, let me choose Rosemary.
It is 1 out of root 2.
Okay, 1 out of root 2. Oh. Okay, so we shall have 1 out of 2 root of 2. Now, once you reach here, you can rationalize and you say, this is root of 2 out of root of 2. In other words, it is always better to have your root in the numerator than having it in the denominator. Please take note. It is always better you have your root in the numerator than in the denominator. So 1 times root of 2, you get root of 2 out of 2 root of 4, which will give you root of 2 out of 2 times 2, which will give us root of 2 out of 4. In other words, what I want you now to start doing, don't leave a numerator in the, don't leave a radical in the denominator, or don't leave a root in the numerator. Let him up this, Dennis, it is okay. Yes, let's not leave a root in the denominator. Now take it up, take it up. Okay, yes, take it.
Sir,
I had to ask about the root of 2.
Root of?
I had to elaborate where we get from the root of 2, like 1 out of root of 2 on the course of 45.
Okay, keep on, don't mute. Don't mute. Okay, how do you get cos 45 from this? Cos is given by?
Adjacent out of hypotenuse.
Adjacent out of hypotenuse. Which is?
1 out of root of 2.
Okay. Have you understood?
Yeah.
Okay. Yes. So like I've said,
thank you.
Okay. We are not leaving our sides in the room. Someone is asking, how do you get sine 30 and cos 45? Scavar we are getting them from those special triangles we have been having. Also sine 30 come. This was here, there was 30, there was 2, 1, and root of 3. So we are getting it from here. Okay, we continue. You are taking a screenshot. You are taking. Yes, 30 and 45 are special angles. Okay, let me first, in fact, emphasize it. 30, 45, 60 are special angles. Whenever you find them in the question, try always to use those special trigonometric ratios we have derived. The roots, those are special angles. And for this number here, I expect you to have your answers in sides. And don't leave a side in the denominator. In case you see there is a side, please go on and rationalize. Okay. Has everyone taken a screenshot? Please just say yes and we'll continue. Okay, yes, people have taken, but I'm sharing it I will share it, the work again in our WhatsApp group. So now, now we are going to what we call the general definition of an angle. Now, angles are going to be paramount when it comes to trigonometry. One thing now we need to know is how is the angle measured? Now, one key thing I want to emphasize is the direction. In trigonometry, the direction is very important. Take it, direction is very important. Whenever we are measuring our angle and we take this direction here, this is the anti-clockwise direction. This direction, all angles measured in that direction are positive angles. And clockwise angles are positive. Angles that we measure, the way the clock is moving, are negative angles. So any angle that you are going to measure, taking this direction, the clockwise, will always be negative. So you put negative 30. So the moment you find yourself getting negative 30, it means that this angle was measured going in the clockwise direction. You find a positive 30, it means that it was measured going in the anti-clockwise direction. Please first take some notes. Okay, first take those key things. I'm giving you some few minutes. When you finish, say done or finished, and we continue. Put it in the chat, but first take those key things. Angles measured in anti-clockwise are positive. Angles measured in the clockwise from the positive x direction are negative. Those are the key things we need to know. Those who are very slow at writing, you take your screenshot such that later on you can check. When you finish, please go on and you take and you tell us in the chat. I'm waiting for more, around 5 people to tell us they are finished, and then we continue. So first 7 people have finished out of the 60. So you want to see who. 8 people, we have said at least 10 people. Okay. Okay, this is good. At least 20 people have finished. We can continue. Okay, that is our first activity. Now they're asking us to draw. I'm going to draw one, you draw the rest. They're telling us that draw a diagram showing the quadrant in which the rotating line OP lies for each of the following angles. On each diagram, indicate clearly the direction of rotation and state the acute angle that the line OP makes with the x-axis. Now here, we are starting part A. I'm going to come and I draw my quadrant. I want you to tell me, we know that this angle is 0 degrees. This angle is 90 degrees. This angle is 180 degrees. This angle is 270 degrees. And we shall have 360 degrees. Kindly just type in the chat quickly, in which quadrant is this angle going to be lying? 100. In which quadrant is that angle lying? Very good. Perfect. It is in the second quadrant. Very good. Now I'll come and I say, you just approximate, don't mind, you approximate that this is where my angle. So remember I've told you always we measure from the positive x-axis. So this angle here is going to be my 100 what? Degrees. Now, I want people to tell me, the angle always, please take it from today onwards, always we measure angle with the reference to the x-axis. The angle that is very close to the x-axis here is always the angle that is needed. The angle that is needed for this one, the acute angle, is the angle we have here. Let me ask people, which angle do we have there? You can use the chart. Which people have already put the angle. The angle is 80. Very good. Hope everyone is seeing 80. Very good. So the angle here is 80 degrees. And now the next thing we need to identify. So they ask us state the acute angle that the line OP makes with the x-axis. So here this is our diagram. And the acute angle it makes is 80 degrees. Full stop, that's where you end. That's what they wanted. The first thing now we are learning is to identify what we call the acute angles, which later on we shall refer to as the reference angles, or what we call the basic angles. Please, members, I want you to do for me part B, and you tell me in which quadrant is that angle lying, and what is the angle close to the x-axis. Don't forget to draw your diagram. I want to see whether people have been paying attention to what we were saying. Tell us which quadrant is that angle. And let me see. People are saying third quadrant, 80 degrees. Third quadrant, that is true. But like I've told you, A negative angle means you are moving in the clockwise direction. So I will start measuring from here. I come, I measure up to somewhere here. Then I will indicate that this is my angle of 100. So the angle that is close to the x-axis here is 80 degrees. So here my answer is going to be negative 80 degrees. Because we have said negative means we have been moving in the anti-clockwise direction. Unless someone has a question, please ask. But in case you don't have a question, I'm just waiting for answers for part C and D. In case you don't have a question, I'm waiting for the answers for part C and D. Yes, Baraka, don't forget to show to indicate that it is negative 80 because it is in the, we are moving in the clockwise direction. So I'm waiting for your answers for part C and D. Type them in the chat. I'm giving you 2 minutes to do that. Okay. See people are saying it is 50. Very good. People are saying the fourth quadrant and it is 50. Rosemary is telling us B is negative 30. Third quadrant. Derek, very good. I'm saying it's beautiful answers coming in. Let's complete. Don't forget to draw. Alvin, that is okay. William, that is okay. Yes, Alvin, you have forgotten to put the direction. Don't forget to put the direction. So when you will see a negative, it means that you are moving in the negative direction, which is the clockwise direction. So please indicate that. Okay. Faith, that is now okay. Carol, that is okay. Okay, K, that is okay. Okay, unless anyone with a question before we leave this part? In case you have a question, raise up your hand before we leave. Otherwise, now we are moving on to the next thing. Okay. We are attempting this now, but first take note of this. Note this down. And then after, I'm waiting for the answers for part A, B, C, D. First take note of that. Acute angle made with the x-axis is sometimes called a basic or reference angle. Then after, you write for me the answers quickly of A, B, C, D. Put your answers in the chat. A, B, C, D. Which answers are you getting? Okay. This is very good. Thank you, people. Keep sending them. Keep sending them. Yeah, I'm seeing very many answers coming in, which is very good. That is very, very good. Now, some of you may be asking, but why are we doing these things? Why? The reasons why we are doing them, one, they are teaching us how we are going to be obtaining the reference angle when we are making calculations. So in case you are getting 70 degrees here, your answer is very correct. The answer is very correct. For part C, in case you are getting 20 degrees, it's very okay. For part B, in case you are getting your 40 degrees, that one is also very okay. You can put negative 40, but good enough. Here we know already that we are moving in this direction, the clockwise. Then for part D, also we expect your answers 40 degrees. In case you have those answers, your answer is very okay. Yes, very good. Yeah, yes. Okay, now we continue. Let me hope we shall have finished by then. Now we have what we call trigonometric ratios of general angles. When we talk about general angles, here we are going to look at the quadrants. And in those 4 quadrants, what we are going to emphasize is the sign for each of those angles. In each of those quadrants, like we know a quadrant comes from quarter. A quarter, meaning you have divided something into equal parts of 4. So this is what we call the first quadrant, second quadrant, third quadrant, and the fourth quadrant. So what do you need to know? That all angles measured within the first quadrant are positive angles. In the second quadrant, people, let me ask some people, you know them. Kindly, if you remember, second quadrant, sine, third quadrant, cos, last one, tan. So that is what we are going to look at. So draw that, and then I know everyone knows how you can memorize that thing. So you draw, and then you write your mnemonic here. But feel free to share with us in the chat. Some of you have very interesting mnemonics. How you are remembering that in this second quadrant, it is sine. Third quadrant, it is tan. Last quadrant, it is cos. So I'm waiting to see how you people, you are. Your mnemonics. Share with us your mnemonics. Mnemonics is something, someone is telling us, acts, another, all students take coffee. All sinners take coffee. All science teachers cheat. All science teachers cane. All science teachers, all science teachers cane. All science teachers take computer acts. This is very too much. All short teachers came. Okay. Please write it there. This is this is very interesting. This is very okay. Thank you so much. At least you have many. You have many, which is okay. So please write what it is that is easy for you to remember. Please just put. Okay, this is very interesting. I've learned many of them that I didn't know. But please put here what your mnemonic is, and then we continue. Can we continue? Can we continue? You can just say yes, and then we continue. But make sure you have drawn this quadrant. You have, okay. Interesting. Interesting. Now we have another one. Now we are going to application. They're asking us that expressed in terms of trigonometric ratios of acute angles, sine 140. Now the first thing you need to know is what we call the reference angle. So I'll come here, I'll come here. I know this is 0 degrees, 90 degrees, this is 180 degrees, 270 degrees, and this is 360 degrees. That is the first step you have to take. After that step, you ask yourself, what am I going to do next? The next step is identifying in which quadrant is my angle. I come and I say, my 140 is in the second quadrant. Come, draw draw something like that to show that this is your 140 degrees. But always, like I've told you, the angle that we are interested in is what we call the reference angle. And that is the angle close to the x-axis. So I don't know which angle are you getting here. Let me see whether people have typed already. Which angle? 40, 40, 40, perfect. Very good. This is now 40 degrees. The next question you are going to ask after getting the reference angle, what is the equivalent when you look at sine in this quadrant? What is the sine? So we know that all are positive here. Students, it is sine. So in the second quadrant, sine is positive. What am I going to do? Since sine is positive, it means that my angle will be positive. So that means that sine of 140 is the same as sine of 40 degrees. Members, just let me know whether you have understood that step. That sine of 140 is the same as sine of 40. Is that clear? Okay, people are saying yes. One person said yes, meaning the rest have not yet understood. Got it? Very okay. Members have understood that. Very good. Now we go to the second one. So the second one, you have cos negative 130. You come slowly, then you are going to draw. And you say, this is 90, this is 0, this is 270, and then this is 180. Then you ask yourself, I want 130. Which direction is 130? That it is negative. I move in that direction. I draw something like this. Then I say this is 130. Then I'm going to come and ask which angle is close to that axis. Yes, I'm waiting in the chat which angle you have. Type in the chat and we see which angle. People have negative 50, have 50. Okay, so this angle here is 50 degrees. Very good. That means the next thing you ask yourself, what is the sign of cos in that quadrant? That we know that all good, meaning that cos here in this quadrant, cos is negative. So what am I going to do? That means that I'm going to write my cos as a negative. So I write negative cos of 50, and that is going to be my answer. So the moment you place cos negative 1/3 and cos of 50, you have put a negative. Please take note, always your reference angles will be positive. Yes. So that the negative, it was to show us where is our angle lying. So which direction are we taking? So that means when you place your calculator, cos of negative 1/3 must be able to give you negative cos of 50. As someone is asking, is it the same as cos negative 50? Now, that is someone like is saying, no. Yes, it is not true. So cos of negative 50, it is not the same as cos of, these are not the same things. They are different. This one shows you are moving in the negative 50. The negative here means you are moving in the clockwise direction. Negative cos 50, it shows you are moving in a positive direction, but you can either be in the second quadrant or third, depending. So that is, they are very different. Members, have we understood that? You let me know yes, and then we see how to continue. Just say yes in the chat, and then we continue. Yes, I've seen. Okay, someone is saying, pardon. Tracy. Okay, good enough. I have another number here. There's another beautiful number. Oh, okay, okay. Tracy, I'm going to, okay. Okay, let us first do this activity. We are doing this activity, but let me give one example for sine 190, such that also Tracy picks up. So Tracy, when you look at this, you are going to first ask yourself, in which quadrant is this angle of 190? That this is 0, 90, 180, 270, and 360. Then you will know that 190 is in this third quadrant. So you draw something like this. So that means I'll have something like this, that is where 190 is. But what are we interested in? We were interested in getting this angle close to the x-axis. And for this case, that angle is going to be 10 degrees. Then the next question you ask that in the first one, all the trigonometric ratios are positive. Second one, only sine. Third, tan. Then you'll have cos. Then you ask yourself, what do we want to find is sine 190? So that means that sine 190 is equivalent to sine of which angle? Of angle sine 10. But in this quadrant, sine is negative, so you put a negative here to show in that quadrant that sine is negative. Tracy, just tell us in the chat whether you have picked that. Tracy, I'm waiting to see your response in the chat, whether it is okay or not yet. Okay, okay, good. Then the rest, let us now do part B, C, and D. I'm waiting for those beautiful answers, part C, B, and D. And I'm going to ask you, there is only one identity I want us to look at. We are going to extend our lesson by 10 minutes. only 10. So, but let us be a bit quick. Do for me part B, C, and D. I'm waiting for the answers in the chat. Seems people are not yet there. I've not yet seen any answer. Hope people are working out. Let's work out. Take our time to work out. Okay, I've started seeing some answers. Okay. People have at least sent for the first number. That is good. Thank you. Kathy is lost again. Kathy, I don't know where you are lost again. You're going to guess the bit challenging. Then we are going to try to do another one until we master this thing very well. I'm going to do part B. When you look at part B, they wanted us to get cos 305. The first thing you do, identify the quadrant. 0, 180, 90 to 70. Which quadrant is this 305? It is in the third. So I come like this. Then I find out the whole of this angle is 305. Then which angle is remaining here? We want angle with the x-axis. So you say 360 minus 305. The answer you get here, you are going to get your angle as 55. That means the next thing you ask that I'm dealing with cos. What is the sign of cos? You know that all T and C. So that means cos is positive. So that means this reference angle you are going to write it as a positive. You say is equivalent to cos of 55. Kathy, hope now we okay. Kathy, let me hope now you okay. Then part C, I expect you to have negative tan of 55. In case that is what you have, you are very correct. Then the last part, I'll expect you okay, the last part, the last part your answer should be negative cos of 65. Okay, so the last one is negative cos of 65. Okay. Yes. How do we get in? Okay. Now I told you for part D, this is how we are going to move. For part D, the angle is 245. What does it mean? It means we are going to move in this direction. So I'll come, I know this is one. I come up to around that part. So what am I going to know? I'm going to know that this angle is 245 degrees. Which angle am I looking for? I'm looking for the angle that is very close to the x-axis, which is this angle here, which is that angle. So this angle is the one that is near the x-axis. But from here up to here is already 108. What about this part that is here? So what you do, you say 245 minus 180. So you end up with 65 as your angle. Then the next question you are going to ask yourself is that, what is the sign of cos in this quadrant that I have all this is sine? That cos here is negative, but my reference angle is 65. So then I will say that cos of negative 245 is equivalent to negative of my angle, which is cos 65. Now, since we're already moving, don't put the negative on the reference angle. Read it the way it is and place it there. What you need to place now is the sign. In which quadrant is it giving you? And always you can even use your calculator to prove that is sine 190 the same as this, then that would be very fine. Yes. Yes, Timos, that is correct. You only get the angles close to the x-axis, not the y-axis. Very good. In simple terms, the angles always, whenever you move, the angles you should get should be these angles here. These angles. The angle you have here is the angle that they are interested in. This is the reference angle. The angle you have here is the reference angle. The angle you have here is the reference angle, even this one. These ones along the y-axis are not needed. We only want the angles at the x-axis. Okay. Any questions? Do we have some questions or it is okay? Okay. Seems it is okay. We are going to go back a bit. There is a number I wanted us to do. Would you be able to try out this number on your own? Let me see what people are saying. Okay, people are saying yes. Okay, take a screenshot. It is okay. The only thing you need to observe, people are saying yes. Yes. So please take a screenshot of that number. but don't even worry. I have an exercise for that. Oh, have we done this? Okay. This is another practice number. Please take a screenshot. Take a screenshot. Take a screenshot. Okay, let me know people have finished. People have finished. Then take a screenshot for this. Those are. Okay. Is it a must to draw the diagram? It's not a must. It's not a must as long as you know how to get those angles. But for easy understanding, you can get them. Okay. Hope that is okay. I think people are very tired. I don't know whether should we end here or people have still some energy. I want to just tell us in the chat. Should we end here or people have more energy? We end. Okay. I think it has been a long lesson. So we are going to end here, and then when we come back next week, we shall be looking at the last part, at another part we call trigonometric ratios. But you may we are going to keep updated on the chat because next week I understand some of you are going back home. Sorry, you're going back to school. Let me hope you took a screenshot. Did you take a screenshot for the last? Please confirm whether you took